Hello, my name is Jaya New from Machine Intelligence and Pattern Recognition Laboratory at Seoul National University. I'll presenting our work, What, How, and When Should Object Detectors Update in Continually Changing Test Domains? Our goal is continual test time adaptation for object detection. Deep learning models often suffer performance degradation when the test distribution differs from the training data. As shown in this figure, the object detector trained with clear day images missed a lot of objects in the foggy or dark scenes because of domain shift. We aim to adapt the object detector effectively and efficiently to the continually changing test domains. Test time adaptation involves adapting the model online to a test domain while conducting inference using only the incoming test data without labels. And continual test time adaptation extends this by considering that test domains can vary over time, requiring the model to adapt robustly and effectively to these test domain changes. Existing methods for test time adaptation and continual test time adaptation include entropy minimization loss and teacher-student network framework for using unlabeled test data, and they update batch normalization layers or full parameters of models. However, these approaches have limitations such as being improper for object detection, inefficiency for online adaptation, and vulnerability to catastrophic forgetting. We address these challenges in three perspectives. The first one is what parts of the model should be updated. The second one is how to update the model object detection. And the final one is when does the model need adaptation or not. The first part is what to update. We introduce a lightweight adapter for each block, enabling the model to rapidly adapt to the test domain while preserving the original object detector to prevent catastrophic forgetting. This approach is applicable to all backbone types such as transformer or resonant as shown in this figure. The second part is how to update for object detection. We align training and test feature distributions using EMA of the current batch test data, considering both image level and object level features. This method ensures effective adaptation for object detection. The final part is when to update. We suggest two criteria to determine when adaptation is necessary and when it can be skipped. Since adaptation requires backward steps, skipping adaptation can increase throughput speed. The first criterion is when the domain gap between test and training exceeds the in-domain distribution gap within training, indicating that the model is not sufficiently adapted to the current test domain. And the second criterion is when there is a sudden increase in the gap, indicating a sudden change in the test domain that requires the model to resume adaptation. We conducted our experiments on Cocoa to Cocoa corrupted, which is consisting of 15 corruption types. Our method improves MAP by 5% compared to direct test case, and our skip maintains MAP improvements while achieving comparable FPS to direct test by skipping almost 90% of the backward steps. In contrast, other methods suffer from catastrophic forgetting over long sequences of changing test domains. We also conducted experiments on the driving dataset shift. Ours improves MAP consistently, and our skip also reduces backward steps by about 80%, significantly increasing FPS. It is the analysis of on-demand adaptation strategy, and we confirm that our approach actively adapts when necessary, especially when the test domain changes, and skip the unnecessary one, increasing computational efficiency. Thank you for your attention. Please visit my website for more information and access to our code. Your feedback and questions are welcome. Thank you.